Hello, I just wanted to do an example of an exponential regression using Desmos, and also to talk about the units that we're going to find in one of our word problems. I think it's number 7, but it's the one about the total personal income being earned by a certain country's population for different years. So let me show that to you. So the problem I'm going to use is this one. So this year, or this semester, it's number 7 in our homework set, but it gives us a table of data where we have our X values are going to be scaled to the year 1957. So it gives us the years and the personal income. These are large numbers. So these are in billions of dollars, it says it's given total personal income of the country in billions of dollars. So in 1957, in this country, the total personal income earned was 408 billion, 600 million, and so on. Notice as we get through this, as they grow, once you get to 1977 and you're up over 1,000 billion, so now when you have 2,312 billion, 0.1, that really means 2,312 billion, 100 million, and so on like that. Okay, so anything in the thousands place represents basically the trillions if we were just going to write that number as in standard form instead of saying times a billion. That's going to become important in our last question on this homework. So, all right, first of all, let's just figure out how do we make our table, put it in Desmos, and then get the exponential regression. It is a little bit tricky, so that's why I'm making the video. So we have the years. It says, let X be the number of years after 1957. So remember, when we go put this data in to a table to do the regression, the 1957, 67, 77 is just going to go in for the X values of 0, 10, 20, 30, 40. And then this last bit is just a 5-year jump. So 45 for the last year. So 2002 is 45 years after 1957. Okay, so this is just my example. So I have already rescaled my X values and dropped this table into Desmos right here. If you're trying to remember how to do this, you can just click on I'm doing a second bar since I already have it in here, and it's under the add. You add a table, and then you can type in whatever you like for your X values and Y values. If you do the copy and paste that they have available for you, when you click on the table in my math lab, it has the full year here. So you'd have to go back. If you're going to try to copy and paste it from that, you still have to adjust your X values. So anyway, these are my X values adjusted to the years 1957 as our start year. And these are the outputs of the personal income in billions of dollars for these different years. All right, so it says, first thing it says is do an exponential regression. If you would like to know why, it did not ask us to do a scatter plot, but once you put a table in like this, a little zoom button down here, when you click on that, it will automatically readjust a window around here to show you those data points. So I'm going to click it, and we can see now why they probably asked for exponential. It's kind of changes slowly the first 2 or 3 episodes here, and then it starts to increase a little faster. So it looks like an exponential function. All right, so here is how we ask for exponential regression, or any regression, really. First of all, we want to tell Desmos that we're referring to the numbers in the table. So instead of just using X and Y, like we would if we were writing a function, we're going to use X1 and Y1 to tell Desmos to use the table's values and the regression commands to compute the perfect values for this function. So instead of saying Y equals A times B to the X, that's our general model, we're going to say Y1 equals, not really equals, A times B to the X1. So let me start that. So Y1, you don't have to hit the subscript. If you hit Y and the number 1, it automatically drops the subscript down there because we have a table already there. Now, instead of equals, we're going to hit the regression button, which is also called a tilde or an approximate. If you look on your regular standard keyboard, it is the key above your tab button, and you still have to hit shift to get to that symbol right there. So instead of equals, this means we're going to do regression on this table up above. Now for our exponential model, we just always use A times B to the X. And I'm going to pull up that off the screen, put my exponent here to the X, and I'm going to use X1 there. Okay, so that's what our exponential models look like in general, a times b to the x1. So it's going to give us a value, it already has down here, giving us the value for the a and the b. However, this is the tricky part. Whenever we talked about these models, the number in front of the base was supposed to roughly represent our starting amount. Now, when you're doing a regression, it shouldn't probably be the exact value, but it should be in the ballpark of the value from your table where x is 0. But look at our table, the value when x is 0, the y value is approximately 400, a little bigger than 400. And according to the regression model down here, it's 770, and then the b value 1.06 says it's growing at around 6%. This is because the log mode button has not been switched on. I don't know why they don't just default it to have it switched on. The log button has something to do with realigning or working and making adjustments to your data set before you run it through the regression formula. If any of you had any chemistry people or physics people that like to use, your teachers like to use log paper, it's kind of an adjustment that log paper also does. Anyway, so when we do our exponential regression, we are going to click this button that says log mode. That's important. And that if any of you are using the TI-84s instead of Desmos, that it operates under this conditions where it's in log mode when it does it in the TI-84. All right, so notice when I clicked that, I don't know if you noticed that the graph changed a little bit. Like watch the graph, and I'm going to click this on and off a couple of times. Now it's off, now it's on. You see how it changes a little bit? Look down here though, when the log mode button is on and it's doing that type of regression, exponential regression, look at the A value now, 442.9. So that's much closer to our initial value. It's never really going to fit perfectly unless all of these points happen to be on the same perfect exponential curve, but that's not likely when you have real data. Okay, so according to this, our data is growing at about 7.7%, something like that, a little bit faster than the other model showed. Okay, so this is the one that we want to use. You do y1 and then the tilde regression symbol a, b to the x1. Make sure the log mode button has been selected, so click on it to check it, and then these are your a and b values. Okay, now the a and b values that they're showing us here in the box are just estimates of a much longer version of those values for a and b that Desmos actually remembers when it's trying to do calculations. And when it did this curve, it was using a longer version of the a and the b. But this is enough for you to type in the rounded answers for part A on the homework problem. Let's go back and look. On the homework problem, it says round to 3 decimal places. And I believe Desmos is showing us, well, that one only shows 3 decimal places. So we don't really know what the 4th decimal place is to be able to round it. So even though it's only showing us 3 decimal places, if you go to the next line and actually type in the value, the letter for the value you're interested in, then Desmos will show you the remaining values that it calculated. So see here, when I just typed A, it's 442.9492466. So it had already rounded that 3rd decimal place, it looks like, up to 5. But it's 5 because the actual values were 4 and then a 6 for the 4th place. So I would prefer, and as would anyone who's doing modeling, to use the more accurate version of these values when we're actually trying to make estimates or predictions. So then you'll notice I'm going to go back here and change it to B just to show you that there's more involved in the B value than what they're showing up here in the regression request. So in the regression request, they have 5 decimals, 07652. Down here, it's 07651951546. So this one is the more accurate version. So they give you estimates up here just to give you a ballpark idea of the values that you're dealing with, but it's actually going to be using the more extended values if you use the actual variables A and B instead of trying to type in these decimals. I say that because once we type this in, rounded to certain places for question part A, write the equation of the function. So that's the model. We want to round it to 3 decimal places. When you get to part B, it says, what will the country's total personal income be in 2007? So now we're just using it like a regular function. So for the regular function, we would like to use this model with where it's actually using these values, but I need to write it like a function. This is just a regression request. So I'm going to go down here and I'll change it to f of x so I can, if I need to, I can plug in different values. And I'm going to use equals, and I'm going to use these same letters, A and B, instead of typing in the numbers for it. So I'm just going to type A, B, to the X, like this. Okay, notice that when I did that, it graphed a black curve right on top of the green one that had been up here in the regression. So if I click on the line 2, watch the graph, it'll change over to green, but it's I guess it's not. I guess it typed on top of it, never mind. Anyway, it's the same exact graph that it's just graphed on top of. And that means it's using the full extended versions. Where'd it go at? I've got a pop-up thing I'm trying to move here. All right. So even though it looks like it's a general case, the A and the B have already been computed. So now Desmos is going to be more accurate when we use this to make predictions. Now, it asks us for the year 2007. Okay, so if we're trying to figure out what X value I'm going to use, because that's a year, so I have to figure out what X value corresponds to that and plug it in up here for the X. So I need to figure out how many years after the original year, 1957, is year 2007. You can do that in your head, or you can just do the subtraction. So it's 50 years later. So this is my X value I'm going to use, 50. Okay, so I'm going to go and I'm going to plug in 50 into the function. So I'm just going to go up to my function notation and change X to 50. So F of 50. All right, this answer down here that pops out, remember this is in billions of dollars as the outputs represent the income. So this means $17,677.67 billion of total personal income was earned. That's actually, if we talk about the standard form of the number, that means it's 17,677,678,221,800. If we're going to go through the whole thing. But right now it's been scaled to represent billions, so that's why they dropped the decimal point right there. But remember, the 1 and the 7, those are beyond the billions place. Now if we're in 1,000 billions, that really means we're trillions. So 17 trillion. So this we would round to the right amount and plug it in for our answer in part 2 here. And then part 3, though, it says, in what year does the model predict the total personal income will reach 21 trillion? So notice that since we're in the trillions, that means that it's going to be, the 21 is going to be in front of the comma. So it's like 21,000 in billions is what 21 trillion represents. So when we go back here, I'm going to think, where does this curve grow up to have a Y value of 21,000 because it's measuring in billions? Okay, so I'm going to adjust my window a little bit and see if I can just use the graph to answer this. The other option would be to take on paper and take this expression and make it equal 21,000 and then use logarithms and stuff to solve it on paper. What I'm going to do instead is use graphing. But to do graphing, I have to make sure that my Y values go up high enough to see 21, I think it said 21,000. So I'm going to make my Y values go up to say 25,000. Okay, so let's look. And it looks like I may need to. So 21, that's going to be good enough because let me make sure it was the right one. I've forgotten already. 21 trillion. But 21 trillion is 21,000 in billions. So I would like to just take this graph and drop a horizontal line at a height of 21,000 all the way across the graph. And right there where it hits the curve, we know that the point on the curve is going to have a Y value of 21,000, which is what we're looking for. And then we need to read off the X value. That'll tell us how many years it's going to take to grow to that height. So an easy way to do that with graphing is to just put in a second function as a horizontal line. And that's what you get when you just type Y equals the number. So Y equals 21,000. There it is. See? So every point on the green line has a Y value of 21,000. So right here, Desmos has already got it identified for us. So if we roll over it, the point where those two cross, so this is the point on that black curve, the exponential curve. The X value is 52.33 or 34 when the Y value is 21,000. Okay, so that's the next thing is how you find that X value of the intersection point. And now we have to go back and think about how that is an interpretation. So when you get to this part C, it's going to say, round your answer up to the next whole number. And I want to talk about why that is. So if we go back and look at this, if the answer is, what was it right over here, 52.33, what that means is we have completed the 52nd year. And we are about a third of the way in, 0.34 of the way into the 53rd year. This is why we always round up if it's an increasing function like this. So that's what we're dealing with. We're going to need to take 1957 and we're going to add that many years to, but we need to add 53 years because that'll be the year that we are in the middle of when it hits this 21,000. So if you look at it, when we're at 52, if I just do f of 52, we're not going to quite be there. 52. See how the answer is not quite up to the 21,000? So it's somewhere after the 52nd year into the 53rd year. Okay, so if the 52nd year ends at 20,000, the 53rd year we can see on the graph, the 53rd year right here, somewhere about a third of the way into the 53rd year, it's going to hit that 21,000. So, what was it? 1957 was our start year. 1957, and then we're going to add, what was it? 53. So the year 2010. So that will be the year during which time the incomes will reach that 21 trillion mark, which looks like 21,000 on the graph here. Okay, so the second two questions were just about how to use a function in Desmos and how to solve an equation when they give you the output using graphing. So in part B, you just figure out what year, what the x value that corresponds to that year is and plug that x value into the function. Then the function you got from part A. And then on part C, when it wants you to find the input for particular output, in this case, they give it to you in trillions. So you're going to go to your graph. You may have to bump up the Y max on your graph to get past this value, but you're going to type in 21,000 or 22,000 or however many trillion it is. You're going to type in that many thousands as a horizontal line, find the intersection point, and the X value of the intersection point tells you how many years it took to get to that amount. You're going to bump that up to the next whole year and then add that to your start year. Okay, so I hope that gives us a little bit to work with if you're trying to use Desmos, still trying to figure out the exponential regression. Remember, you do the exponential regression command to check that log box to make sure that it's in log mode, so you get the same kind of answers that my math lab does. Okay, so I hope that helps, and I'm going to go ahead and get this uploaded so I can get that out to you.